Okay, hello grade 9. Let's take today lesson 4 and 5 in unit 5 because they are related to each other, which is called cyclic quadrilateral and its properties. What is cyclic quadrilateral? Cyclic quadrilateral, this is the quadrilateral whose vertices belong to one circle. We can draw a unique circle passing through its 4 vertices. If we draw a circle pass through a quadrilateral, the vertices of the quadrilateral, so it is cyclic quadrilateral. Cyclic comes from circle. So in the opposite figure, ABCD is a cyclic quadrilateral because its 4 vertices lie on the circle. What are the properties of cyclic quadrilateral? From where that I know that this is a cyclic quadrilateral? I can know it by one of these 3 properties. Maybe each 2 angles are drawn on a side of its sides as a base, and on one side of it are equal in measure. Like this is similarly like what the converse of theorem 2 we took, that the 2 angles are suspended to the same base and on the same side of it have the same measure. Their vertices are on an arc of a circle and its base are chord of it. You remember when we say last time that if I have 2 angles and they are equal in measure, this angle and what is this angle and this angle, if they are equal in measure and on one base like ABCD, so this is on one, 2 angles are drawn on the same base, which is for example AB, and measure C equal measure D, then the points ABCD lie on a circle and AB is a chord of it. So here it is the same. These are 2 angles on the same base, on the same side of the base. Okay, or each 2 opposite, one of the properties of the cyclic quadrilateral that each 2 opposite angles are supplementary, and the measure of the exterior angle of any of its sides, okay, or any of its vertices equals the measure of the interior angle. Which one of the 4? It is equal to the interior angle opposite to its adjacent. Adjacent means beside it. Where is the interior angle beside this exterior? This one. So it is not equal to this one. We know that there's some 180. It is equal to the opposite to its adjacent. And we will talk about each property later on. In the cyclic quadrilateral, each 2 angles drawn on a side of its sides as a base and on one side of it are equal in measure. If this is cyclic, so measure of angle A equal measure of angle D. Why? Because they are 2 inscribed angles subtended by the same arc. ABCD is a cyclic, then BAC equal BDC drawn on BC and on one side of it. Generally in this figure ABCD we can deduce the following. First, I can deduce that measure of angle 1 equal measure of angle 2 because they are on one base, which is BC. Or I can say that measure of angle, for example 3 equal measure of angle 4 on the same base DC. Also I can say that measure of angle 8 equal measure of angle 7 on the same base BA or AB. And the last angle I can deduce measure 5 equal measure 6 on the same base AD. Okay, and the line segments AB, BC, CD and DA, also AC and BD are all chords in this circle. If I draw a circle, this will be a chord. Each one can be, I can name it a chord in the circle. Which of the following figures in a cyclic quadrilateral explain your answer? Of course I will not do them all. Let's start with number 1. Here in number 1 I have this angle, for example 90. All of them of course will be 90. In this triangle EBC, if this one 90 and this one 50, so the third angle will be 40. As you see here, measure ADB becomes equal to measure ACB equal 40 degrees. So as you see on one side AB, on the same base AB and on one side of it, so this is a cyclic quadrilateral. This one missing here, there is a side missed here. Okay, I have triangle BDC. measure B 50, measure C 40, so measure D 180 minus the sum of the other two, it will be 90. And given that measure angle A 90, so BAC equal to CDB, both of them 90 on the same base BC and on one side of it, so this is also a cyclic quadrilateral. The third one, I have here 99, angle ADB 41, AD parallel to BC. What you will deduce here from parallelism? I will deduce from parallelism that measure of angle ADBC equal 41 degrees. In triangle, for example, if I name this one MBC, you can get the missing angle. You will find it is 40. Okay, of course, 41 here and 41 here, they are not two angles which are on the same side of one of the bases. Which two angles are on the same base and on one side of it? Measure ADB and measure ACB. These two angles on one base AB and on one side of it. 41 and 40, they are not equal, so this is not a cyclic quadrilateral. In the opposite figure, AB is a diameter in circle M, X is the midpoint of AC, XM intersect the tangent of the circle B and Y. Prove that the figure XAYB is a cyclic quadrilateral. Cyclic quadrilateral, so I'm searching about one of the properties, the two equal angles or the two opposite supplementary angles and so on. Let's see here what is given. The given is X is the midpoint. If X is the midpoint in one of the chords of a circle and this line comes from the center, so this is the first theorem we took. So this is perpendicular. MX will be perpendicular on AC. So angle AXY is 90 degrees. Also, if we looked at what else I can prove? Yes, I have a diameter and a tangent. So if I have a diameter and a tangent to the circle, so they are perpendicular on each other. So AB perpendicular to BY. So this angle also equal 90. As you see here, angle AXY equals to ABY. AY is the same base and on one side of it equal in measure. So this AXBY is a cyclic quadrilateral. Okay, another example, ABCD is a cyclic quadrilateral. This is given that ABCD is a cyclic quadrilateral with diagonals intersecting at F. X belongs to AF, Y belongs to DF, where XY and BC are parallel. First, I want to prove that the small quadrilateral here is cyclic. I will make it bigger a little bit. I want to prove that XYCB is a cyclic. Let's see from the given. I have two givens, main givens. ABCD is a cyclic quadrilateral. It means that this angle equal to this angle, the base DC. If I took the base CB, so angle A, this part of A will be equal to this part. If you took AD as a base, so angle B all equal angle C, or ABD equal DCA, and so on. And I have the parallelism. From the parallelism, maybe I will find corresponding, maybe I'll find alternate or interior. Okay, let's see from the cyclic what I will deduce. From the cyclic, the one which I will need, that measure of angle DAC equal measure of angle DBC. The base DC common and on one side of it. So here angle ADAC, I will for example name it 1 and this is 2. So angle 1 equal angle 2. Measure of angle 1 equal measure of angle 2. Okay? From parallelism, AD parallel to XY and AF is a transversal. So angle, the small angle Y, XF, which I will name it 3, equal to angle 1, Y, corresponding angle. Angle 1 equal to angle 3, corresponding angle. If I name this one 1 and this is 2, from 1 and 2, I find that measure of angle 2 equal measure of angle 3, because 1 equal to 2 and 1 equal to 3. So 2 will be equal to 3. If we looked at them, you will find that their name is YXC and YBC, and they are on the same base YC and on one side of it, so YXBC is a cyclic quadrilateral. Second, he wants to prove that XBY, this small one, XBY equal to YCX. I want to prove that these two angles are equal. Briefly, that I have just proved that BXYC is a cyclic quadrilateral, so of course that angle YCX equal XBY on base, the same base XY, and on one side of it, so they are equal in measure. Okay, let's take this drill. Also, this is a circle M. X and Y are two midpoints of AB and AC. I want to prove, first I will make it also bigger. First, I want to prove that AXYM is a cyclic quadrilateral. AXYM. Let's see the angles. I have two givens. X is the midpoint of AB, and AB is a chord, so MX will be what? Perpendicular, so this angle is 90. The same with AC. Y is the midpoint, so measure MYA is also 90 because it is perpendicular. As you see, AXM become equal to MYA, the base MA, and on one side of it, so AXYM is a cyclic quadrilateral. Second, I want to prove that measure of MXY, this small part, this small angle, equal to MCA or MCY. As you see, they are not related to each other by any line or by anything. So I have to think to join between them or to get something in common. Okay, what I will get is, for example, if I have just proved that MAXY is a cyclic quadrilateral, so measure of angle MXY, this angle, for example, I will name it 1. Measure of angle 1 will be equal measure of angle 2. Why? Because on the same base MY, and on one side of it MAY and MYX. MXY. So these two angles are equal measure. Measure 1 equal measure 2. At the same time, measure 2 equal measure 3. Why? Because MA equal to MC, because they are two radii in the circle. So this is an isosceles triangle. The base angles are equal. So measure 2 equal measure 3. From 1 and 2, measure 1 will be equal to measure 3. Okay? Then at the end, he wants me to prove that AM is a diameter in the circle that's passing through the points AXYM. Why did he say the points? Because we have proved that AXMY is a cyclic quadrilateral, but when he wrote the question, this one is not proved yet. So since this one angle, we said that at the beginning that measure angle MYA is 90, so AM is a diameter. If I draw a circle here, and this is 90, so this is the diameter of the circle. Okay, let's take theorem 3. Theorem 3 says what? Theorem 3 says in the where is 1 and 2? You will ask, where is 1 and 2? 1 and 2 were in the previous lessons. He is numbering the theorems during the lessons, not each lesson from 1 and so on. So theorem 1 is in the first lesson, theorem 2 in the second, and there is theorem 3. In the cyclic quadrilateral, each two opposite angles are supplementary, and we said this before in the properties. In each of the following figures, find the value of the simple used. Supplementary mean their sum equal 180. By the way, this is y. So here, this is a cyclic quadrilateral. The vertices touch the circle. So each two opposite angles are supplementary. So measure B plus D equal 180. So 2x plus 7 plus 107 equal 180. Complete the equation. 2x plus 114 equal 180. Take 114 to the other side, and then 2x, see what 2x equal to. Then x will be uh, 33. Okay, and then I want to get y. 5y plus 4y also equal what? Also equal 180 because they are supplementary. So 9y equal 180. So y equal 180 divided by 9 equal 20. Sorry, 20, not 60. Okay. The same here. X plus 15 equal plus 115 equal 180, and so on. They are not difficult. Okay, here find with proof. I will solve this one because these two, because they are more complicated than A and B. For example, this one, A, B, C, D. You want the measures of the figure A, B, C, D. Here they are given. I have the arcs. I have AD arc 80 and DC arc 60. I can do construction and draw BD and AC and get the angles, but no need for this one, because simply this is the diameter. So the measure of the arc AB will be 180 semicircle. So still I want the measure of arc CB. So it will be 360 minus 60 plus 80 plus 180, or 180 plus 60 minus 60 plus 80. It will be 40. Why do I get this? Because if you looked at the sides, the vertices of the cyclic here, or the figure, you will find that they are inscribed angles. So if, for example, if I want to get measure A, DAB, one of the angles, if I want measure A, it is opposite to which inscribed, opposite to which arc? It is opposite to arc DCB, which is 60 plus 40. What is the inscribed angle equal to? What is the relation between the inscribed angle and the measure of the opposite arc? The inscribed equal half the opposite arc, because the arc, the measure of the arc equal the measure of the central angle, and the inscribed equal half the central. So the inscribed equal half the measure of the arc. So measure A equal half the opposite arc, so it will be 100 divided by 2 equal 50 degrees. Similarly, I will do this with angle, for example, B. I want measure B, this angle. It is opposite to CDA. CDA equals 60 plus 80 equal 140. So measure B will be half 140, it will be 70. I can do this with angle C. It is opposite to 80 plus 180 and get its half with angle D, or I can get it by what? I can get it by the supplementary. I know that each two opposite angles are supplementary, so I can get measure C 180 minus A, which is 50, so it will be equal 130. Measure angle D will be 180 minus the opposite angle, which is 70, equals 110. Let's see number D, the measure of the figure ABCD. I want ABCD. First, I have here parallelism, and I have measure A 95, measure CDE 28. Okay, first I want to get measure, for example, B. This is parallel, so the sum of the two interior angles equal 180. So measure angle B will be 180 minus 95, so it will be 85. Okay, if I looked at ABCD, A opposite to what? Opposite to C. So I can get measure angle C. Measure angle C equals what? Equals also 180. Here not measure angle B all. This is measure angle ABE. Not angle B all, because angle B has two parts. Measure angle C all equal 85. Okay, so this is 85 and this is 85. What else? What else? I want to get what else? Okay, if I looked at measure of angle EDC and measure of angle CBE, this will be 28. Why? Because they are two inscribed angles subtended by the same arc EC, so they are equal to 28. So now I can get measure B all. Measure B will be 185 plus 28. So it will be 85 plus 28 equal 113. Measure angle D that he wants in the quadrilateral ABCD equal 180 minus 113. So measure of angle D equals 67. 180 minus 113. Okay, this is an example. ABCD is a quadrilateral inscribed in circle M. ABCD. M belongs to AB. CB equals to CD. Measure BCD equal 140. First find measure of angle A. So easy to get measure of angle A because this cyclic quadrilateral. So measure of angle A will be 180 minus 140, so it will be 40 degrees. What about measure of angle D? He wants D all. Okay, it is two parts. I draw, it was not drawn BD as construction. I'll draw it because I want to divide measure D into two parts. First, I want to get, for example, this one. This is diameter and this inscribed angle in half a semicircle, so this will be 90 degree. What about the small part? The small part which is CDB, this part. As you see, CB equal to CD and measure C 140, so I can get the base angles of this isosceles triangle. 180 minus 140 divided by 2, it will give you 20. 20 plus 90, so measure angle D all will be 110. Okay, so the theorem says that in the cyclic quadrilateral each two opposite angles are supplementary. What is the corollary? I have a corollary here. The measure of the exterior angle at a vertex of a cyclic quadrilateral is equal to the measure of the interior angle at the opposite vertex. This means that if I have here a circle and I have a quadrilateral inside it, which is cyclic quadrilateral, it's inside the circle. I draw it like this, for example, and I name it ABCD. And I will take any of the exterior angle, for example, this exterior angle. But something wrong here. I'll draw it like this. This exterior angle, why it is equal to the opposite to the adjacent interior angle? Why this angle equal to this angle? Because if you see this one, I name this one 1 and this one 2. 1 plus 2 equals what? Supplementary angle. This exterior, the exterior angle with the its adjacent. 1 plus 2 equal 180 because they are supplementary. At the same time, this is quadrilateral, so the sum of the two opposite angles are supplementary. So the opposite angles are supplementary, so their sum, if I name it the 3, so angle 2 plus angle 3 will be also 180. So 1 plus 2, 180. 2 plus 3, 180. Right? So I can deduce from here that measure of angle 1 will be equal measure of angle 3. If you subtract 2 from here and 2 from here, you will find that 1 and 3 will become equal. That is the meaning of the corollary. Okay? Let's see some of these drill. Let's take, for example, number 1. I want measure of angle X and measure of angle Y. This is exterior angle. It's equal to what? It's equal to the measure of the interior angle. Which one? Opposite to its adjacent. Okay? So measure X will be equal to measure A equals 75. This is the adjacent, so opposite to the adjacent. It's adjacent. So measure X will be 75 degrees. What about measure Y? Measure y, it's an exterior angle. It is equal to the opposite anterior to its adjacent. So it's supposed to equal to this angle. I don't have this angle, but I can get it from the supplementary angle. So 80, so this angle will be 180 minus 80 equals 100. So measure angle y will be equal 100 degrees. Okay, let's take number 3. I want also x and y. Let's study the figure well. I want x and y. And you want the x is so easy. They are opposite angles, so there's some 180. So measure of x will be 180 minus 120 equal 60 degrees. What about measure angle y? As you see here, I have EBF equals 65. Okay, but this is not the exterior. The exterior, all this part. So what can I do? I have what else? I can use what? I got this 160. I will use the parallelism. Where is the parallelism? The parallelism is here. DC parallel to BF. So letter Z is clear now. So angle C will be equal to CBF. So this part equals 60. Equal to angle X. Okay? So the exterior angle CBE will be equal 60 plus 65 equals 125. And this exterior angle equal to the interior angle, which is opposite to each adjacent. So angle Y will be equal to the exterior angle. So angle Y equals 125 degrees. Okay? Moving to another part, when the quadrilateral is cyclic, or how to prove that the quadrilateral is cyclic. Some of them we took it already. The quadrilateral is cyclic quadrilateral if there is a point in its plane at equal distances from its vertices. If I have point M and MA equal to MB equal MC equal MD, then ABCD is a cyclic quadrilateral. Also, the quadrilateral is cyclic if there are two angles equal in measure drawn on one of its bases and on one side of this base. This is, we took it many times. Here angle D equal angle C, the base is AB, angle D equal angle A, here is BC, and so on. This is, we talked about it before. Okay, I have some remarks here. If there are two angles drawn on one of the bases of the quadrilateral and on the same base of it, on the same side of it, and they are not equal in measure, like this one, if C and D are not equal, so the quadrilateral is not cyclic. And this is very clear. Okay, so if the angles, the two angles, any of these two angles are not equal, so the quadrilateral is not cyclic. The rectangle, square, isosceles, trapezium, okay, these are one of the quadrilaterals, are cyclic quadrilaterals. If you see rectangle, square, or isosceles trapezium, they are cyclic quadrilaterals. But the parallelogram, the rhombus, and the trapezium, not the isosceles trapezium, they are not cyclic quadrilaterals. This is very important remarks. What is the third thing I can prove with it that the quadrilateral is cyclic? The converse of the theorem. We took the theorem says that if in the cyclic quadrilateral, two opposite angles are supplementary. And the converse, vice versa. If two opposite angles of a quadrilateral are supplementary, if you find that two angles, their sum equal 180, then this quadrilateral is cyclic. So if you find that measure B plus measure D equal 180, or measure A plus measure C 180, so the figure is cyclic quadrilateral. If one of the cyclic, I would say this remark on the diagram here. If ABCD is a cyclic quadrilateral, and as you see, measure A and measure C equal 90, they are supplementary, there's some 180, and then what? Then BD will be a diameter in of the circle, of the circumcircle of the figure ABCD. If I draw the circle, in this case, if this is 90, BD will be the diameter of the circle. If I draw a circle here, BD will be its diameter, and M will be the midpoint of BD. Okay, and of course it will be its center. The radius, it will be MB is a radius, MD is a radius, MA is a radius, MC is also the radius. So if I have measure A plus measure the two of the opposite angles are 90 degree, it means that, as you see here, that BD is diameter of the circumcircle of this figure. Okay, in each of the following figures, prove that ABCD is a cyclic quadrilateral. I want to prove that it is a cyclic, so one of the previous things we said. Okay, very easy, I think. Number one, if you add 97 plus 83, you will find what? You'll find that there's some 180, so this is a cyclic quadrilateral. For the second one here, okay, this is a triangle. I have 50 and I have this 35. You can get angle B, 180 minus 50 plus 35, it will be 95 degrees. These angles opposite to each other, when you add them, you will find they are 180, so they are supplementary, so the quadrilateral is cyclic. This one I have AD equal to AC. This is C. So this angle will be 40. So the vertex angle in the isosceles triangle will be 180 minus 80, so it is 100. Add the opposite angles, 180, it is 180. Okay, so again, to prove that it's cyclic, so if the points are at equidistance from the point in the plane, so it's cyclic, or if the cyclic or the angles, we said it before, or the converse of the theorem 3, which say that the opposite angles, if they are supplementary, so the quadrilateral is cyclic. The fourth thing that you can prove with it is a corollary. If the measure of the exterior angle, and we took it as a property, and if it is a cyclic quadrilateral, so this is a property of it. If I want to prove it is a cyclic quadrilateral, so this must be verified. One of them, yeah. Okay, so if the exterior angle at a vertex of a quadrilateral is equal to the measure of the interior angle at the opposite vertex, then the figure is cyclic. Okay, so if measure CBE equal to measure D, then the figure is cyclic. And also if I draw the exterior from here, so measure, for example, FCB equal measure A, so it is cyclic. And if you draw from here, and so on. Let's see this drill. We have only drill and an exercise. Prove that the following figures is a cyclic quadrilateral. This is 86. You can get the rest of the angle. This is supplementary, 180 minus 86. So this part will be 94. As you see, this is an exterior angle for the quadrilateral. It is equal to the opposite interior for its adjacent. So it is 94. So this is cyclic quadrilateral. I want to prove it. So of course it will be. Okay, and this one, angle ABD 30 and AD equal to AB. So this angle also will be 30. 180 minus 60. So this part is 120. So as you see, 120 exterior angle equal to the opposite for its adjacent. So it is cyclic. And the same here. It is so easy, of course. AD parallel to BC. So this is interior angle. This angle will be 180 minus 74. It is 106 degrees. I have CF bisect the angle, so 53. And this is also 53 because they will be equal. 53 plus 53 equals 106. So they are equal. So the quadrilateral is cyclic. The last example in our 2 lessons today. This example, AB is a diameter in circle M. AC and AD are 2 chords in it, and in one side from AB, a tangent to the circle was drawn from B. This is a tangent, and intersect AC at X and AD at Y. Prove that. You see the yellow one? YDCX is a quadrilateral, cyclic quadrilateral. Okay, let's use the givens we have by a simple way. I will use the givens. I make it bigger a little bit. Okay, what are the givens here? The givens here that I I have to draw here BC. I don't want it. Yes. Okay. I'll draw BC here. This one BA is a diameter. So measure of angle ACB will be what? Will be 90 degree. It will be perpendicular, so this is 90. Okay. From this given, please concentrate. This is C. So measure angle CAB plus measure CBA will be what? Will be 90. There's some 90. I don't know how many degrees is XAB and how many degrees is CBA. I know that if I also name them 1 and 2, I know that measure of angle 1 plus measure of angle 2, it will be equal to 90 degree. Okay, and I have another important given, the tangent. AB is a diameter and BX is a tangent. So measure of angle ABX, this angle is 90 because it will be perpendicular. The same I did here, angle ABX, ABX, you will find that measure of angle 1 plus measure of angle 3 here will be equal 90. There's some 90. Measure 1 plus measure 3, it will be 90. Okay? So 1 plus 2 equal 90 because they are this angle is 90, and measure 1 plus 3 equals 90. As you see, 1 is repeated. So which angle equal to which one? Now angle 2, I will write it alone here. Angle 2, which is this one, this part, angle CBA, this angle, equal to angle AXB. Is it this clear? Till now, is it clear? Okay. So angle, this angle equal to this angle. Okay? Okay, let's see. That I know it is not very clear, the drawing, but we have to look at it very well. Okay? So look at it again very well, please. Okay, look at YDCX. What can you find here? What can you find? Okay. You'll find that measure of angle, we have proved that ABC now equal to AXB. These are equal in measure. Okay. Okay, let's see measure of angle YDC. This angle, it is exterior angle of the cyclic ABCD. There is another cyclic here, AB. This is a small one, ABCD. This is cyclic. Okay. Okay, so measure of angle YDC, this angle, it is exterior to which one? It's exterior to the quadrilateral ABCD. So it is equal to which angle? It is equal to the opposite, the interior angle opposite to its adjacent. This is the adjacent. So it is opposite to this one. So angle YD, measure of angle YDC will be equal to measure of angle ABC. Okay? And ABC was equal to what? Was equal to AXB. This is the first thing we have proved. We have proved that these two blue angles are equal. And now I have proved that measure YDX, it is exterior angle for the quadrilateral inside the circle. So angle YDC equal to angle CBA. And this was equal, so these two parts will be equal. If you looked at them very well, you will find that angle AXB is exterior angle for the quadrilateral CDYX, and they are equal, so the quadrilateral is cyclic. So again, since in AX angle AXB, this one is exterior angle at the vertex of the quadrilateral XYDC, and YDC is opposite to it, so the XYDC is a cyclic quadrilateral. Thank you, grade 9. Miss you a lot and hope to see you soon. Thank you.